Welcome to today's Detection Dispatch. I'm Jade Calano here at Anvilogic. We have these detection dispatches every 2 weeks, so feel free to sign up. We'll have the reoccurring meetings on your calendar. If you don't want to, go ahead and delete that, but please don't. We love you. So stick around. We're gonna have a great time today. I'm joined today by Sota Aoki from Rakuten and Rohith Kondeti from our very own Anvilogic. We're going to be talking about how you can defend against MFA attacks techniques with both Anvilogic and Splunk. I'm going to turn it over to these guys to introduce themselves, and we'll get started.
Sounds good. All right, sounds great. Just a brief introduction about myself. My name's Sota. I'm a security engineer at Rakuten, based out in Tokyo. My main responsibilities and roles include building, deploying, fine-tuning use cases in order to find gaps and fill those in, and then also to increase our security operations center's maturity as a whole. I've been in security for about 4 years. I've been using Anvilogic for about 4 years now as well, and been loving it.
What got you into security?
This was just I would say just based on luck. It was a job rotation, and I got placed in security, fell in love with it, and here I am today.
I do feel like that's the story for a lot of us. You know, you just kind of fall into it, you start like leaning over, what is that? And then it's hooked, it's in your blood, you can't get out of it.
Exactly. So.
Yeah.
Awesome. Rohith,
that's exactly what happened to me too.
Yeah?
Right? It was purely luck based. I work in the forward deployed engineer team in Anvilogic right now, part of customer success. Where I work with customers, pre-sales, post-sales, working with people like Sota to be able to integrate Anvilogic into their organizations. Prior to this, I used to work at a large financial institution, working in their security operations center, working for their CSOR team, where I started the journey off as an analyst, working my way up to be the lead for a threat hunting and content creation team. But my journey was also pretty much luck. There was a breach right when I joined. I was actually supposed to be part of an investment banking division, and they started pulling off all new hires. And they tapped into me as well as one of the new hire grads, and I fell in love with security. It's one of those things I always wanted to be like Hacker Man back in college, but security really wasn't developed in college at that time. I know now there's a lot more full-fledged courses and degrees out there, but it's great to be in this field.
Nice. We all got our hoodie degrees.
Yep.
All right. So we're going to be talking today about both understanding MFA attacks. What is it? What do you need to be looking out for? Why they matter? How can you start handling it? Common detection searches, issues, how we can address them, as well as we'll give a full-out demo and how you can apply this not to just MFA attacks, but across the board in other attacks that might have the same methodology that you can use. So getting into multi-factor authentication, what is it and why does it matter?
Sure. So multi-factor authentication, or MFA, is really a security feature, right? That requires users to use 2 or more forms of authentication that lets them log into online systems or accounts.
Okay, so we all know this. You have your Okta that you have to sign into, or you have Google, or pretty much anything where it's like, do you want to set this up?
Exactly.
The answer is yes, set it up. If you're not, if you're in security and watching this, come on guys, already do it. But so when we get into this, most people are probably doing multi-factor authentication today.
Exactly.
How is it used beyond that? Why do organizations leverage it?
Yeah, so they use it to protect themselves and invoke that extra layer of security. Really, this is centered around protection against emails and security systems and corporate environments, really to protect. It usually involves something. When we say multi-factor authentication, it's usually involving 2 or more of something you have, something you know, or something you are. So Jade, you kind of just touched upon this, right? With things like authentication apps. So that really all falls under the criteria of something you have. So this is going to be things like smart cards or tokens or OTPs, which are going to be one-time passwords.
Okay. We've talked about what it is. I think we all kind of know what it is. We've talked about different pieces, but what is the importance of beyond all of this?
Sure. So, one of the main reasons that customers leverage it is because of stronger security, right? And this involves protection against data breaches, phishing attacks. A lot of times it helps against identity theft as well, and even protection against emerging threats. And there's a couple other benefits that organizations leverage as well. This is going to be, compliance with regulations, better user experience, It's pretty easy to implement as well, and it gives a lot more added visibility to IT administrators as well as security practitioners like Sota.
Yeah, so now that Rohith has kind of refreshed our memory on what MFA is and the importance of it, let me just briefly explain what MFA attack is and how it happens. So the MFA attack happens when the attacker gets a hold of the user's MFA credentials through a credential breach, purchasing it through the dark web, brute forcing it, or any other means possible, and then sends multiple push requests to the victim user. Just try to get them to accept just one of these so that they can gain access into their internal environment. So simply put, this attack takes advantage of social engineering, sends multiple push requests to the user, just overwhelms them, and wears them out to where in the end they'll bypass the MFA measures. So it's an extremely simple attack, but obviously, if executed successfully, it can be very, very dangerous.
Seems like typically, your attackers are going for the point of least resistance. So if you can get it in the simplest way with the biggest bang for your buck, you would do that.
Exactly. Yeah, and then just want to go into some public examples of how even well-known organizations have fell victim to this simple yet effective attack. The first example might be the Uber internal IT system breach, which happened in September of last year. So in this attack, initial access was gained through the attacker finding credentials on the dark web. Then they leveraged these to send multiple push notifications to the victim, imposing themselves as an internal IT team member. This basically overwhelmed the Uber employee, allowing access to the attacker in the end. And as a result, the attacker was able to exfiltrate data from their environment.
It just seems like such a simple thing. How do teams miss it?
Yeah, so I think this goes into some of the detection side as well. But without any logs, there is no visibility to actually understand your typical or anomalous app access patterns. So this is where teams have to become more security teams have to kind of change in terms of detecting these attacks. Okay, and then there's another example actually, which is the Cisco VPN compromised and lateral movement activity, which happened in May of last year. For this attack, initial access was gained through actually a compromise of a personal Google account, which contained Cisco credentials. And again, once credentials are obtained by the attacker, they sent multiple push requests to the victim, followed by some sophisticated phishing attacks. And this convinced the user to now allow the attacker access into multiple Cisco systems. Fortunately for Cisco, they did report that no vital data was exfiltrated, but it just comes to show that if it wasn't addressed and mitigated promptly, it could have ended up much worse.
Are these the cases where you hear, oh, there was a breach and it was just happening and, the attackers were in there just hanging out for a while, or maybe you go multiple weeks or months without even knowing anything happened? Is that kind of this situation?
So I think for the Cisco case, they were able to find them more quickly, which is why nothing major had happened. But obviously, this could go the other way around, where the attacker stays in your environment for extended period of time and just starts exfiltrating large amounts of data from your environment.
You don't have the right detection set up, or
exactly. But now that we know that even well-known organizations can fall victim, just want to go into how organizations can actually protect themselves from this attack. So on the preventative side, we obviously have conducting user awareness training. So like I mentioned previously, this attack takes advantage of social engineering. So just educating your employees and users on the fact that this type of attack exists is very important. Another technique might be to enable time-based one-time passwords or number matching. Like compared to your conventional push notification method, this technique requires the user to input a randomized generated number in addition to your MFA credentials. And the nature of this just decreases the possibility of the user mistakenly allowing the attacker access into their internal environment. And that, last but not least, just limiting the number of authentications that can be sent to the user. By doing so, you can simply just avoid the issue of overwhelming your employees from unwanted or unknown push notifications in the first place. And then on the detection side, we have onboarding logs for visibility. Obviously, without any visibility of logs, there is no way to understand the traditional or the typical or anomalous app access patterns. And then obviously, once you have your logs onboarded, you can always build and deploy use cases to now actually detect on these abnormal MFA activities.
And speaking about building use cases, right? We have a variety of different use cases we can go ahead and build. If we're kind of talking about Okta and MFA in particular, we can be looking at things like MFA being deactivated, or MFA being reset, right? Even MFA being updated. These are all different types of alerts that gets produced in the logs that you can go ahead and build detections out for. Even new devices being enrolled. And this sometimes can get tricky because some of these use cases or detections might end up being very noisy. And that kind of takes us off to our next portion, which talks about how do we address MFA, especially in terms of a detection perspective, and how do you address alert fatigue when you're building out these type of detections, especially ones that sit in the egress point. Anything really related to MFA and attack fatigue. How do we take these type of alerts that are producing so much noise, but still get value out of them?
So I have a question here. So there's the alert side with the alert fatigue, and obviously you can value, and I'm sure you'll go into the sequencing and all of that. But taking a step back on the detection side and all of these different types of things, I mean, teams are pretty overwhelmed. Who's writing all of these detections? How are you deciding that, because you're having to keep these detections updated as well. Like, are you just going through a list and checking them off and saying we have to do all of these detections? Or are you picking and choosing? Like, what does that look like?
Yeah, I mean, that's a good question, right? So a lot of times this really falls on the onus of these detection engineers to really go ahead and do their research, understand what in the web they can pick up on, really get intimate with the log set itself and the tools, and what are the different types of alerts you can leverage. Lucky for customers that are using Anvilogic, a lot of this is already being done in the Armory. So you can go ahead, type in things like Okta or MFA, and see, we've already built out a whole suite of detections that you can easily go ahead and just add to your workspace and deploy right out of the bat.
Yeah, and this is exactly what we've leveraged at Rakuten, where before it would have been really difficult for us to actually visualize what kind of techniques were actually covered. But now with Anvilogic, we're able to visualize where we're covered, where we're not, and if we're not covered, it's easily just out of a box deploying, very simple, fast, and that's how we were able to protect ourselves from the MFA attacks as well.
And one of the things we want to get into now is kind of talking about the framework, right? So what exactly are we doing with these type of detections? So if we took something like new devices being enrolled, this might be happening almost hundreds of times within an organization, right? Especially if an organization is large enough and they're constantly onboarding new users and things of that nature. How do we really weed out the noise? So one of the things we like to do is get into this mentality of building out scenarios. So before we get into scenarios, and really what that entails is a pattern-based detection from one use case to another. So instead of just one singular detection firing, what we want to do is ensure that if a particular rule is just way too noisy, how do we still get value out of this? Is by saying, maybe this use case by itself, firing alone, is not beneficial, but we want to sequence it with another detection following in sequence, either before or after it. And this kind of increases the fidelity of the alert.
Yeah, because some detections just have to be firing and they're going to have to be noisy.
Correct. Right? So, one of the things we do, leveraging the Anvilogic framework is we'll go ahead, we'll gather the data that we need. We'll go ahead and do the actual detection piece of it, looking for that exact specific type of detection or use case. Once we have the events filtered out, then we actually normalize the data using normalization macros. And this is a very important step, especially when you're dealing with a variety of different data sets, especially if you're looking at authentication logs or endpoint logs or even network logs. You're looking at multiple different data feeds that all have a particular field name, like source IP, called in 10 different ways. Right, so this could be SRC IP. This can be just source. This can be just source IP spelled out differently. So really, what we want to do is we want to ensure that everything's kind of normalized to the Anvilogic's common information model through our data model. And once that's there, then we actually table out the relevant fields that we need. and ultimately output this into what we call the Anvilogic index, which is very similar to like a hunting index or a summary index that you can go ahead and store these interesting signals in. Once we have a list of all these interesting signals getting created, that's when we tap into the actual correlation and the scenario building, right? Where we then tap into this index and say, hey, this particular event followed by that, a different event can be very interesting to build these correlated detections.
Okay. So as we're coming to you live from Las Vegas at Splunk's conference, this is, there's a lot of sessions that I've been going to around detection as code and detection engineering in general. And a lot of people, it looks like they're doing this in YAML and building Python. It just seems really manual. So at Anvilogic, obviously, this is the framework that we're applying, so you're not having to do those automations
Correct.
yourself and like keep those updated as well.
Correct. And our platform, our no-code scenario builder, makes it very easy for you to create these custom detections as well. It's a simple plug-and-play approach where you can go ahead and either do certain use cases followed by another use case, or some of the detections that we've done at Rakuten involve almost like a MITRE tactic and MITRE technique followed by other use cases as well.
So I guess, Sota, what were you doing prior to Anvilogic? Like, were you having to do this manually? Like, walk us through that process.
Yeah, right. So before Anvilogic, we were using obviously Splunk as our main SIEM, and we were just, as we were only using the enterprise license, we were having to manually create our use cases with SPL. But obviously, because we're starting off with a really small team, nobody was really familiar with SPL. It made it difficult for us to actually, make new detections in a prompt manner. And this was causing a lot of issues, obviously, because in security, speed and quality is an important factor. So I would say before Anvilogic, we were facing a lot of issues in terms of, creating new detections.
That makes sense. I mean, finding people to do it or just taking the time to figure out what you need to build or all that.
Exactly.
Okay.
Yep.
Getting out of the having to learn the SPL or SQL or KQL or whatever the languages are. Let's get you guys out of the data learning and language processes and more into the security side of it.
Correct.
So we're going to jump into a demo right now of if you walk us through what they're going to be seeing in the demo.
Sure, absolutely. So basically what we're going to be doing is looking at the Anvilogic platform itself, walking you through a couple, Okta-based use cases, showing you how to implement it, walking through the actual SPL itself, understanding the framework on how you can take this and, again, apply it not just for MFA, fatigue attacks, but also outside of it and leveraging that framework where you're storing these normalized events in a summary or hunting index and then building these interesting scenarios, these correlated searches on top of it to build higher fidelity alerts. What we're going to show you now is how we can put together what we've learned in the slides and into practice. What I'm showing you here is the Anvilogic platform that will apply some of the manual work needed to come up with the logic for some of these use cases, but the essence of what's shown here can be done in core Splunk. The first thing we're going to do is go ahead and look for Okta to see what different types of detections come up in the platform for it. And right away, you can see there's different detections for profiles being updated, users being created, users being impersonated, MFA updated, and so on. What we'll do is actually just stick with the first one, which goes ahead and looks at multiple Okta push requests. And this is a detection that looks for when a user receives multiple push requests for authentication via Okta. So the first thing we'll do is go ahead and look at the Splunk-based rule, which will go ahead and actually give you the logic associated to this. Every single rule found in Anvilogic uses what we call code blocks, and each of these code blocks references a handful of different macros. The idea of this macrotized approach is that it makes it a lot easier for you to create a repeatable framework that makes it very easy to build detections off of. So the first code block will be referencing the Anvilogic get macro or the data retrieval macro. This is typically where your index information or source type information sits. So in this case, information around the actual Okta index will reside here. Once you point to the right data set, the next thing we want to do is actually filter down on the relevant events. In this case, we're looking for system push, send factor, verify push events. Once we have that initial event type, the next thing we want to do is actually normalize the data. And we're normalizing data using an AVL map application data macro. The
contents of this macro will be where a lot of that normalization that we mentioned before is done. So in this case, you can have source IP being called a variety of different ways, depending on which log set that we're looking at. Or source user itself could be called in a variety of different feeds that are referencing it in multiple ways. What we want to do is normalize all of that using one core coalesce statement that makes it very simply to say the next time a source user is called, it is always called in a consistent manner, regardless of what the actual raw field name might be. Once we have the normalization done for all the core fields and have them mapped to the common information model, what we want to do is just call back the relevant field names that might be important for this particular detection. We also have an allow list macro where we can go ahead and do any sort of allow listing or whitelisting. And in this case, this is actually based off of the parameter of the rule name itself. You can also group events if you'd like. And ultimately here, we're actually filtering out where the signature itself is greater than 4. This way we know that for this particular rule, 5 or more hits is what constitutes as multiple push requests. The next thing we have is an enrichment macro. Within here, we can go ahead and do any sort of CMDB or asset or identity enrichment associated with this rule. So if you have any sort of user enrichment or asset enrichment, this is a great place to store that information. Ultimately, we have a one-liner for AVL definition that'll go ahead and replace some of these tokenized field names with the field values. And the last thing we do is we call this AVL head collect command, which is responsible for writing the output of these events into a hunting index or a summary index. And the benefit of this is that we want to reference the summary index to do additional correlation, which we'll show you in a later section. So now what we're going to show you is a safe search associated with this rule. What we'll do is we'll actually take the first portion of the code block and actually run this for the last 48 hours. And you can see that as we are running this actually comes back with almost 108 results. Now, we don't want to go ahead and look through every single one of these results. So we'll go ahead and actually add in some of the additional code block. So we can see that there's activity coming from a variety of different users getting this send factor verify push message. Instead of seeing every single one of them, we'll add in the remaining logic, which will go ahead and actually do some of this filtering, where we'll only look for activity coming from a particular user with at least 4 hits. And in this case, there's only 5 results that are left, all stemming from this one particular user. Now, when these results are finished, we want to go ahead and write that to that Anvilogic index or that hunting or summary index so that you can go ahead and view these interesting events either at a later time, alert on them, or go ahead and leverage some of the noisier results for additional correlation. So one more rule that we're going to look at today will be centered around MFA reset or deactivated, which is going to be looking for specifically when Okta user MFA has been deactivated or reset. And in this case, the specific event types we're going to be looking at is user.mfa factor deactivate, user.mfa factor reset all, or system.mfa factor deactivate, all of which could be contributed to some sort of deactivation or resetting of MFA. Again, we're going to be following a very similar structure in that after that initial data retrieval and filtering is done, we'll normalize our data set. We'll still call the relevant fields that are necessary. If there is anything associated with allow listing or whitelisting, we'll add that in here, grouping of events, enrichment, that one-liner for AVL definition that quickly tells what happened, along with writing those events to the Anvilogic index or hunting or summary index. In this case, what we'll do is we'll go ahead and copy the logic and then test this, which will go ahead and bring up the rule. And when we go ahead and actually run this logic, we will go ahead and see that there will still be a handful of events that come back. In this case, we almost see 10 different events coming back from a variety of different users associated with either resetting via email factor, soft token, or a variety of other reasons that Okta lists. Next, what we'll do is we'll want to go ahead and investigate correlating these two individual rules in a sequential manner. So the next thing we want to do is, instead of looking at each one of these alerts by themselves, put them in a situation where we can go ahead and correlate them to produce a higher fidelity alert. And we can achieve this through the concept of threat scenarios. First thing we want to do is go ahead and give this a use case title, where we can say Okta multiple push requests followed by action on objectives. The next thing we want to do is go ahead and give this a definition, where we can say activity associated with multiple push requests, and then followed by either MFA reset, policies being modified, or authentication happening from suspicious countries. So the way we achieve this is through a sequential stage scenario, where we can start off with the first stage involving Okta multiple push requests, where we'll go ahead and choose that particular rule. And subsequently, if that rule fires, followed by an additional stage, where within here, we'll go ahead and again just look for Okta-based rules. And in this case, we'll choose some policy, MFA factor being reset, or authentication from suspicious country. Activity, instead of 60 seconds, we'll say 60 minutes. And instead of activity happening from the same host, we can say correlated off of the same user. Because we're storing all this information in the Anvilogic summary index or hunting index, wherever that may be, it allows us to transact between different rules based on how we save them. So we can copy the logic and go ahead and have this run. And we'll see within the last 24 hours, if we run this, there is one hit from Anvilogic test at anvilogic.com. More specifically, we can hover over and see that there's two rules that are firing for this. So Okta MFA reset or deactivated, Okta multiple push requests. If we wanted to visualize this, we can visualize this in Anvilogic's triage dashboard, where we go ahead and say this is Anvilogic test at anvilogic.com. The two particular stages that are responsible for this. And clicking into the first one, we'll go ahead and drop down the actual events associated with this particular role.
So that was our detection engineering dispatch for this week. Like I said, stay tuned for bi-weeklies. Please tell your friends. Let us know if there's any subjects or topics that you want to know about more, and we'll dive into those in future weeks. Really appreciate you all joining us. For those of you who joined us, we do have free detection code that we will send out to you, so you can see that in the follow-up. Stay tuned for those. And thanks for joining.
Thank you.
Thank you.
Bye.